Hello and welcome along to a video about the hazards of volcanic activity, otherwise titled, What's Going to Kill You When a Volcano Erupts? Well, we're going to take a tour around the world. This is going to help you with your A3 poster, and we're going to visit a whole bunch of places to find out about the hazards that can be associated with volcanic activity. Now, the reason why we're doing places is partly to make sure that we increase and develop your spatial awareness of these tectonic processes and hazards around the world, but also because to give you a sense of being able to talk about the detail that you'll need to score well in the exam, to be able to tell the actual stories of places is going to be really helpful. And then finally, if you have to evaluate in any sense the impacts of these volcanic hazards, you will need evidence to back up your opinion, and what better to provide evidence than a number of these stories and examples. But before we jump into those in detail, let's take a quick look at the overall list of hazards that we're going to be looking at here as we go through. So we're going to be looking at lava flows, lahars or mud flows, pyroclastic flows, and we're going to be looking at ash. The other thing that isn't on here that we're going to be looking at will be some of our poisonous gas. Okay, so let's jump on in, and the first location that we're going to go to is back down here to Hawaii. We've been here a number of times before, and this time we're going to be taking a look at the different hazards from lava flows from this shield volcano. Well, actually a couple of shield volcanoes. There's Mauna Loa. This one, Kilauea, is the one in particular we're going to be taking a look at. So have a look at the key down here to the left, and I wonder, can you describe the pattern here of lava hazards? Pause the video and have a go at describing that. Okay, so what you should have seen is there's definitely a north-south pattern. The north part of the island, the north third of the island or so, the hazards are very, very low. And as you move down here in towards the south two-thirds, southern two-thirds, the hazards go up. You'll also see here very much along this linear pattern where you have the extremely high hazards, right? So that one in particular is the one that we're going to be interested in. We're going to go in and have a particular look at the Kilauea eruption. Now, I talked about this linear pattern. Here is Kilauea, the volcano itself, and there's the crater in towards the center. But we zoom out a little bit more, we can see here, this is where the linear pattern was, and there is a linear pattern here. So if we have a look at the key, this is where your fissure eruptions was taking place in 2018. Right, what do those fissure eruptions look like? Let's go and have a wee bit of a look at this. And the fissure eruptions come out in the form of what are known as lava curtains or lava fountains here. Now, if you take a look at what's happening here, you'll see that these are coming up. These lava curtains are coming up and pretty fast. It looks like the lava is quite fluid here, but this is no surprise to us because this is a shield volcano. And what we know about shield volcanoes with the, what type of lava is it? It's the basaltic lava, that's right. The basaltic lava that comes up, it doesn't really hold on to its gases. So when it comes up to the surface, here's the lava just erupting at the surface, and the gas just comes out. It's not being stored up, and it's throwing that up in tens of meters into the sky. Now that looks absolutely beautiful. I wonder how dangerous would it be if you were standing there. Is this a case of you having to say, oh no, let's run for the hills, here comes the lava? Well, no, because the lava flows here, once ever they come out, they tend to form a bit of a skin on the top of it, and underneath they may be flowing a little bit faster, but the lava flow on the surface and the front edge in particular doesn't flow particularly fast, and therefore you can move out of the way. In terms of your social impacts, these lava flows are relatively limited in terms of the impact of life in particular. So that's the lava fountains coming out. Let's go and have a look a little bit further in here at the nature of this. So they're not going to really cause much hazard in terms of the death risk from people, but if you take a look here at all of these houses, here comes the lava flow along these fissures and out they come. And of course they're into this inhabited, well, previously inhabited area, because you can certainly move the people out of the way. Can you move the buildings? Not at all. So the economic impacts and the damage to the infrastructure can be really quite significant when it comes to these lava flows. So let's follow on down and see as we come towards the edge here. This one is quite cool because it shows you those lava flows moving out at different rates. You can see the time scale here you're going over. There's the time there. It's going through a number of different weeks and months, and you can see what's happening here as it comes out of the fissure. Right, let's wait for it to start again. It comes out of the fissure, then down here towards the sea, and then this big flow here, and then it spreads out along the coastal area. And you can see it very much taking place over a period of weeks and indeed months. So it is very much the kind of thing where you can move people out of the way, but you absolutely can't move buildings out of the way. If we come in here to this little coastal area here, and we'll click on this to see what has happened. Open that image, and here we go. Here is the lava flow beginning to arrive. This is June the 3rd. By June the 5th, 2 days later, it's moved that distance. All of the buildings are completely wiped out. So in terms of economic impacts, this really can be very considerable. In terms of the impacts on human life, they can move away, so it can get out of the way quite quickly. Now, get a sense of the scale. How much further? 1.5 kilometers out to sea of all that new land that has been created there by that lava flow. Okay, now those are your social and economic impacts of the lava flows. Let's go over here and take a look at some of the environmental impacts of the lava flows. Let's click on this and see what this is showing us. So this is a lake in Hawaii called Green Lake. A freshwater lake, was a lake I should say, 0.8 hectares, the largest freshwater lake in the islands. But on June the 2nd, 2018, the lava entered this, and within 5 hours it had evaporated all of the water away. There's the steam of the evaporating water, and it completely evaporated the water away, and it filled basins. So that is one of your environmental hazards of the lava flow. Okay, so that was our first example of a lava flow. That's Kilauea in Hawaii. Let's zoom back out again. Let's go to the global overview. And the next place we're going to go to is our old friend Hawaii. Hawaii is definitely a place where Iceland. What am I talking about? Iceland here is a good place for us to go and visit whenever it comes to volcanic activity. We're going to visit here a couple of times during this video, but the first time we're going to come to is this little island just to the south of Hawaii called Jaime, and we're going to go all the way back to 1973 to a time whenever the volcano erupted on this island. Now there is the volcano, it's a cinder cone, but very similar to Kilauea. This was a fissure eruption that erupted here. So if we have a look at this, we can absolutely see something looking very, very similar to what we've just seen of those lava fountains going up there. Again, it looks very dramatic. This is actually the evidence of the gas escaping continually so that you're not getting these massive explosive eruptions that you'll get with a composite volcano. So there's no major threat to life. In fact, you can see here there was a rather large settlement here. They were able to evacuate the people off the island whenever that eruption started. So the issue here wasn't your social impact. Your issue here was your potential economic impact, because this island was largely dependent on fishing for its economic activity. And you can see here the fissure eruption, the lava fountains going up, and you can see here the hint of what the issue is. The lava was starting to head towards the bay. It was coming over here. And you can see this new land that was created. Here is the lava flow by the 28th of January. And here by the 30th of April. Again, notice the time scales in this. So people, plenty of time to evacuate. Houses, not so much. But the big challenge here in the case of Jaime was if this harbour had been cut off, the economic impacts would have been considerable. So how do you stop a lava flow? Well, the short answer is not easily, absolutely not easily, because they weren't able to do that in Kilauea, but they were able to do something pretty special here, because they pumped vast quantities of seawater onto the front of the lava flow here to try to get it to solidify and act as a kind of natural dam to stop the rest of the lava coming behind it. Did it work? Well, yeah, it did. In fact, you can see here that in the decades since, there's a spit has formed there. So it did actually work here. But that's the one and only time I've heard of that happening, and it certainly didn't happen in Kilauea. In fact, I should have mentioned in the way I passed Kilauea, the damage there was something in the region of $800 million, making it the most expensive, devastating volcanic eruption, economically speaking, in the United States of America since the famous Mount St. Helens in 1980. Quick mention again of the environmental impacts. The lava will completely cover whatever was down there before, but here we can see all these years later, what are we, nearly 50 years later, and you can see that the vegetation is starting to regrow again. So those are our two examples of our lava flows. Next up, we're going to go to the place which is actually our case study later on, and it's Volcan de Fuego in Guatemala in Central America. So let's zoom on in there to see where we're at. A little bit of the tectonic context of Central America. This is a converging plate margin, which means in the way that we're referring to it, beginning with D, it is your destructive plate margin with your trench, and here is your characteristic pattern of volcanoes. Two words you're going to say about this: linear pattern of volcanoes, parallel to your trench. So this is your hydration melting as the subducting plate goes underneath the other plate, causing the partial melting production of magma. And in this case, what type of volcano? Well, these are your composite volcanoes. So these are the volcanoes that are going to erupt in much more dramatic fashion. So let's zoom on in here to Volcan de Fuego. Let's zoom in just to give you the context of it. And what we're seeing here, let me see if I can find the right key. We'll come back here. This is the major hazard that we will discover in our case study. This is your pyroclastic flow. Now you'll see that the pyroclastic flow in this case has come down in a very linear pattern following the valleys, because the pyroclastic flows are denser than air. These are extremely hot. You can be up to 1,000 degrees centigrade. They're very fast. They're far faster than you can ever hope to run. And basically when one of these is coming for you, you are in big trouble. The heat of them will be extremely dangerous to you. It will burn exposed skin, it will burn your lungs. In many ways, if you're lucky, you will die very quickly. This is the kind of thing that did for the people in Pompeii. So if you have that in your image, in your mind, you'll get a sense of what's happening here. Now let's take a look at this. This shows us a little bit of that pyroclastic flow. This is obviously after the volcano, and the pyroclastic flow as it comes down, this cloud of death coming down very fast that engulfed these areas, and then this is it settled afterwards. You see some of the impacts of that. Now let's have a closer look at some of the areas that were affected. Here is the golf course that was affected, but you can also see that the pyroclastic flow is affecting some of these areas in red, which are the settlements. And as we will see in our case study later on, this is where some of the greatest devastation and loss of life occurred. Great tragedy here in this. Now, what about the areas that will go? The pyroclastic flows are density currents, so they are denser than air. They will flow down the side of the volcano. They tend to follow some of the valleys, so that in a sense makes them a little bit more predictable. How far out will they go? As well, measure the distance of this one's about 10 kilometers. So you're measuring these in kind of 5, 10, 15, 20 kilometers, that kind of thing. So these are going to be areas that are relatively close to the volcano. Now, if you remember from what was said before, your composite volcanoes aren't particularly wide. So the diameter of this one's about 12 kilometers. And if you come out, get rid of that for a moment. If you come out from there, say 15 kilometers, you'll see that you're beyond the actual cone of the volcano into the flatter land around, and you are into the area and the territory where people might live. And that's what makes these so dangerous to the people living nearby. Now, next up, we're going to take a look at the lahars. This is your volcanic mud flow. And we're going to see some of the considerable damage that can be caused by that. This is a great tragedy, this story, the story of Nevada del Ruiz in Colombia here, and in particular Armero. So let's zoom in to the volcano itself. And what we've got here is the hazards map that was produced in advance of the volcano. Now, first of all, let's get a wee bit of a sense of the scale from the volcano to the edge of the lahars here. Now, what we're seeing here is that these are much greater distances than we've just seen for the pyroclastic flows. In fact, the grey areas here show the areas potentially affected by the pyroclastic flows. So it goes a little bit further there, but you can see you're measured in those similar kinds of scales that we've seen in Fuego. And even smaller again, here you have your hazard from your lava flow. Now, this isn't surprising that the hazard is relatively small. This is a composite volcano. This is produced by your andesitic magma erupting. The andesitic magma tends to hold on to its gases, and therefore, unlike your shield volcanoes that we've just been looking at, these tend to produce your much more explosive eruptions, producing your tephra, which is your ash, and your volcanic bombs, and your pyroclastic flows, and all kinds of things like that. And it's only later, whenever the gases are mostly released, that you'll be getting your lava. Well, you might get some as a hint of the volcano erupting as well, but they tend to be more localized because this lava is more viscous. But the big risk here is your lahars. Now, in particular, the distance from this volcano to Armero is nearly 50 kilometres. Now, if you think of the distance from Lurgan to Belfast, is about 30 kilometres. So you're talking about going from Lurgan to Belfast and then another 20 kilometres away from the feature that did this. This, in other words, is a volcano that you'd be aware of if you lived here, but you would probably think that you're well away from the danger zone. It's also far enough away that you not even realise if it erupts, because you may not notice it. So let's have a look at the tragedy that unfolded here. Unfortunately, despite the fact that this hazards map existed before the eruption, it wasn't really paid attention to by the authorities. They did not respond to it. They did not order an evacuation. And tragically, whenever this volcano erupted, because of the height of the volcano, it melted some of the snow on the top of it, and that produced your devastating lahars. And down these valleys, they travelled very, very fast. This fast flowing flood of water and gloopy mud that is very, very hot because it's been produced by the volcanic eruption itself. And all it came down here towards Armero, this town. And here's where the Armero tragedy unfolded. Turn that layer off for a moment and you can see it. Well, you can see what's left of it. You can still see the road pattern here. You can still see where the settlement was, but it's completely wiped out. It's devastated. And the big tragedy was here, and this was a massive tragedy. In Armero and the surrounding towns and villages, 23,000 people lost their lives as a result of this lahar, nearly 50 kilometres away from the volcano. As we'll see later, this was a massive wake-up call to the volcanologists community. This tragedy, which in many ways should have been an avoidable tragedy, was a real shock to the scientists and a real catalyst to get them to see if they could do something about that, to try and get the authorities to realise the dangers and pay more heed. We'll talk about that later. But in this case, what I just want you to see here is all these years later, there's just some hints of the buildings left. This was a town that was completely wiped out. The socio-economic impacts of this were vast. The main road through the centre has been reinstated. It's as a major thoroughfare in the area. And if you drive down there, you'll see the first floors, not the ground floor, but the first floor of many of these houses, because the lahar just buried them. Now, in terms of the environmental impact, you can see that the few decades later, and it's just all grown back. In fact, the soil will be fertilized by it. So the environmental impacts in the longer term aren't too great. But the human tragedy of this, particularly because it was so avoidable, remains to this day one of the worst volcanic eruptions and tragedies of the 20th century. But let's come back to Fuego again. This will be our case study. But the major issue in the early stages, of the initial stages of the eruption with Fuego, was this pyroclastic flow. But here's another reason why the lahars can be a danger in the longer term, because they can be a danger after the eruption is finished. What you can see here is places where the ash can come out of the volcano and cover areas. Now, this may, in this case, not be a major threat to people and human life, but it's what happens then afterwards, because if this ash then gathers in this unconsolidated manner on top of the volcano. So let's have a look at this again and you'll get a sense of it. That the ash there and the remains of the pyroclastic flow is not consolidated. That's just basically your tephra lying on the ground. Now, whereabouts are we in the world? Let's remember, zoom on out. The clue is probably a bit of a hint there, and even the colour of that. This is in Central America, so you're in your area where you're going to be having more rainfall here, close to your tropical rainforests. So this is an area where you're going to get a lot of rain, and what will then happen after the ash and the pyroclastic flows come out, even if there's not a lahar immediately, there can be a lahar following on in the days, weeks, months, and indeed years afterwards. So if I turn on this layer, this was a hazard map that was produced in the immediate aftermath of this eruption, and you can see here's our key here, the pyroclastic flow debris. Again, this is mostly contained in towards the center of the volcano itself. They're just estimating that within a few kilometers. There'll be nobody living there because it's actually on the cone of the volcano itself. But if you look at the lahars, these are traveling much further down away from the eruption itself as well. So they produced these in the days after the eruption to try to warn people of the potential hazards. We'll see these again in the case study, how this map worked. It was produced as a GIS map. We'll have a look at that, and looking at different scenarios of different rainfall totals, and really looking at the threat that this could pose to people. But again, if we get a sense of the distance, let's bring in the measure tool for this. From the volcano, you're coming out here, in this case, up to about 20 kilometers away. But you can see how many people are potentially living in that area who are under a longer term threat from your lahars. So that's our lava flow, our pyroclastic flow, our lahars. Let's jump across to Pinatubo, 1991, and we're going to be taking a look here at mainly the ash. Now, Pinatubo is one of the biggest eruptions in the 20th century, and it was so big and it put so much ash and gases into the atmosphere that it actually changed the temperature of the entire world. It led to a little bit of global cooling for a few years, and it shows you how volcanoes can influence the temperature of the planet, even on that global scale. But this was the first major eruption after the Armero tragedy of 1985. This was the first time that the volcanologists had had a chance to try and persuade the authorities to respond to the hazard. Now, what you're looking at here is the hazard map. Let's have a look at the key again for this. And there you've got your pyroclastic flows. Let's have a look at the distance, shall we? What kinds of distances are we talking here? So the main blast of it again is less than 10 kilometers. You're coming down here to some of these river valleys, so around about 10 kilometers away, maximum distance there, 17. So you're again getting that similar kind of radius, and the worst ash they were forecasting in a similar kind of area. But what are these brown things here, orange things? These are your pyroclastic flow, or your lahars. So you again see similar kinds of distances to those that we saw in Nevado del Ruiz and the Armero tragedy. The good news was that they got the forecast much better when it came to this. They managed to forecast and read the signs of the potential erupting volcano, and they evacuated lots and lots of people out of some of these areas that were most at risk from these. Well, they got the forecast pretty good, but there was one thing that they underestimated when the eruption came out, and that was the ash cloud itself. So the ash cloud was more like this kind of distance. So if we put this on here, we can see that the ash cloud is coming up to kind of about 50-60 kilometers away. So it affected a much larger area than was first thought. Now, what did that look like when it came out? Here we go. So this is 40 kilometers away. This is the US Navy base. There was one that was on the island there, very close to the mountain, very close to the volcano, and you can see the amount of ash that's there 40 kilometers away. And you can see here the damage and devastation that's going to cause to some of the environmental areas. The plants themselves are collapsing a little bit under the weight of that, so there might be short-term damage. There's also, you probably can guess from this, going to be short-term damage to agricultural land. Crops are going to be destroyed. Now, that ash, however, will relatively quickly fertilize the soil a little bit better. So that's part of the reason why you get so many people living near volcanoes, because these materials come out in the longer term are going to give more fertile conditions for the people living there. But in the short term, the environmental impacts are really quite considerable. Here we have an example of why the ashfall in this particular case were so devastating, because the ash that's sitting on top of the buildings, 2, 3, 4 inches thick, may not be particularly devastating in and of itself initially. But the Philippines, hey, we've gone to the Philippines before, haven't we? Remember Typhoon Haiyan? Yeah, it's right in the target area of these tropical storms. It gets a lot of rain. Very similar to Guatemala. And unfortunately, just after the volcano erupted here, there was a tropical storm came in, dumped a lot of rain. The ash absorbed the rain, and it got much heavier. Now, if you think of a sponge that you take that is completely dry, you put it in water, it soaks up the water, and it becomes much heavier. And what you see here is some of the buildings that were destroyed and devastated by that, and that's what killed some of the people in this eruption as well, because the ash went out much further than they were thought and first were estimating, which meant that it's very easy to find these images of people being evacuated out of the area that has already been affected by the ash. Now, just while we're here, we'll take a wee look at a couple of these things as well. This the pyroclastic flow. This is a very iconic image of the Pinatubo eruption. This little small van in the foreground trying to run away from this. Did they make it? I don't know. But what you're seeing here is these ground-hugging, denser than air, travelling faster than you could outrun, superheated, horrible walls of death that are coming barreling towards you. Absolutely horrible way to go. Fortunately, as we see from the things that we've looked at, these are relatively contained to the proximity of the volcano itself, but they do come out beyond the typical radius of your cones of your composite volcanoes into areas where people live, and this is one of the biggest reasons for deaths. And of course your lahars. This image can show the damage. Now the bridge is gone. Do you see the bridge up here? Bridge is damaged. You can see the damage done by the lahars coming down. There's the bridge. And here you can see this little trail of cars maybe finding ways in the hope that they'll be able to ford across the river. So you can see some of those devastating impacts in the immediate term, but remember, lahars can be a hazard in the longer term. This is ash from Pinatubo, now forms the forms the wall of the gorge in the Tarlac River. And it demonstrates how much volcanic material remains on the slopes of the volcano. This continues to pose this threat of lahars because that is unconsolidated. It's not rock, it's literally piles of ash and other tephras that are just piled up there. With the rain, you can see the gullies of water coming down through this. That's extremely easily activated by the rain and can be carried downstream and trigger lahars even years later. Okay, that's lava flows, there's pyroclastic flows, it's lahars. We've had a look at ash. There'll be one other place we'll look at in ash in a moment, but we're now going to go to Cameroon. Whereabouts in the world is Cameroon? Let's zoom out a little bit. It's in Africa. Now, a little bit about the tectonic context here of Cameroon, because this isn't somewhere we've visited before. Cameroon is not on a plate margin. It's not part of the East African Rift Valley where we've been used to these linear lakes before and all of the stuff in the Afar region of the Danakil Depression of Ethiopia. So what's going on here? Well, you can still see that there's something of a linear pattern of volcanoes here, and the truth be told, we don't really know what's forming these, whether it was a former hotspot that maybe tried to be active whenever Pangaea was splitting up, and maybe it's fired off some of these volcanoes or whatever it is, but there is a linear pattern there that makes it kind of look a little bit like a hotspot. But the thing that we're going to be most interested in as we come into this Lake Nyos here in this part of Cameroon, around about an area we have a number of these volcanoes and fissure eruptions that are taking place. And what we're seeing in Nyos is probably the worst example and the greatest tragedy that I'm aware of volcanic gas. So let's have a look at the story of what happened with Lake Nyos. So here's a little bit again of your tectonic context here, your Cameroon volcanic line. We're not entirely sure what it was that caused the volcanic activity there, but potentially related to some breakup of Africa from South America. Whenever Pangaea was breaking up, there is Lake Nyos, a volcanic crater lake, and here is the tragedy that unfolded here. Basically what happened is, as the gases that are coming out from the volcano come into the lake, in the warm tropical climate of Cameroon, the warmer water at the top forms a kind of a cap over the entire lake. So the gases that are coming up, like sulfur dioxide, carbon dioxide, coming up the ground, become very concentrated at the bottom of the lake. Instead of these gases just escaping in levels that were low enough not to cause any harm or damage or death, they build up and they build up and they build up. You get this gas-rich water at the bottom. Now, it's not entirely certain what it was that caused this, but most people are thinking that it's a small earthquake that caused a landslide, which brought some water in, or some material into the lake, which stirred the water up. And that allowed the gas-rich water at the bottom, the colder water, to come up towards the top and escape. And what you then had was what's described as this explosive degassing. You had about 1.6 million tons of carbon dioxide forming a layer about 160 feet, about 50 meters deep of carbon dioxide above the lake. Carbon dioxide is denser than air, so it flowed down the side of the volcano and travelled for about 15 miles. Now, carbon dioxide is a trace gas in the atmosphere, less than 1%. The percentages here, 68%. Carbon dioxide leads to almost immediate unconsciousness, and death. And you had It's devastating impact here as it just came out and killed so many people and animals in the surrounding area. Something in the region of 1,700 people are thought to have lost their lives here, and over 8,300 livestock were killed by this as it just came down and wiped out so much of the life. Now, if you take a look here, you'll see something of the pattern that it followed. Now, again, there's a very definite pattern to these things. Many of these hazards, as you're probably noticing, are following this linear pattern because they're coming down the river valleys and formed this linear pattern here to the northwest and this linear pattern here to the northeast. And this is the pattern of the locations where these dead bodies were found. Dreadful tragedy. Okay, so that's your lava flows, and our examples of our lava flows, Kilauea and Jaime. You've got your pyroclastic flows, and your example of that in particular is Volcan de Fuego in Guatemala, but you've seen some of those in Pinatubo as well. We've got our lahars, and our primary example of that is Nevado del Ruiz and Armero, although you can see lahars in any of these composite volcanoes, so they're there in Pinatubo, and we'll see them also in our case study of Volcan de Fuego. And we have seen our poisonous gas and a particularly tragic example of Lake Nyos in Cameroon. Okay, to Iceland again, so let's come out to our global overview. We're leaving behind Cameroon and we're coming up here to Iceland, and we're going to go to Eyjafjallajökull. So we're coming to this volcano that erupted in 2010 in the southern part of Iceland. So in this part of Iceland, we've got two very tall volcanoes next to each other. So here is Eyjafjallajökull, which is a composite volcano, 1,666 meters high, and beside it is Katla, which is a shield volcano, which is actually just about 150 meters lower than Eyjafjallajökull. But just a quick reminder here, look at the diameter of the shield volcano compared to the composite volcano. There's much more cone shape. It's just a little bit of a reminder. But what we're mostly interested in here is this, which is our Jökulhlaup, which is the glacial flood that can happen whenever an eruption takes place. So let's have a look here. So the glacial floods, or the Jökulhlaup, was triggered as part of the 2010 eruption. About 800 people were evacuated. We'll take a bit of a look at where they are and where they were evacuated from in a moment. But you can see something of the flood waters that came down as a result of that. This is a photograph from a plane. Here's a map showing it. It comes out to the front, or to the north here, sorry, follows down the river valley and down here towards the sea, these glacial floods. So there was a warning system was really put to the test here because these are potentially very devastating. And as I said to you before in a previous video, this is one of the only volcanoes in Iceland where people that could be affected by the Jökulhlaups are living within less than an hour away. And we saw the increase in the discharge, also increases in temperatures were noted as the Jökulhlaups came down and people were evacuated out of the way. Now, if we take a wee look here, we'll get a bit more of a sense of the relatively low population densities in these areas. These are larger settlements here, and so of Fullsfjörður, or however that's pronounced. If you've ever been to Iceland, you probably have been here. Vik, this is one of the famous black sand beaches near Vik. So this is an area that perhaps some of you have been to. But this is relatively low density area. Let's go in and have a look at some of these places that are being represented here. They're just individual little farmsteads, that kind of thing. But you can certainly see that there are plenty of people here that are living close to the place where this Jökulhlaup came down, and there are certainly homes that are very, very vulnerable to the flooding depending on the nature and the extent of that. So it was important that these areas were indeed evacuated. And in this case, the prediction of the Jökulhlaup was largely very effective, and the people were able to be evacuated away. But just while we're here, let's finish off by taking a look at the ash here again. This volcano, the Eyjafjallajökull, is famous, of course, for causing flight disruption all across Western Europe. But before we come to that, so let's take a look at the area here where localized ashfall was more than a centimetre deep. So you can see that although the Jökulhlaup isn't really affecting too many of the settlements, thankfully, the ashfall is, and a number of these are farms in the area. So let's take a wee look at what this actually looked like and what the implications of this ash would be. So there's just another map showing that rough area of where it is. There's Vik down there, and there's the Eyjafjallajökull and Katla. There's the area being affected. But what did it look like? Well, here's some of these buildings, as you can see, some of the farm buildings here, and the ash just coating everything. So you can see the environmental impacts of that as well, just coating everything that's there. Any crops are going to be damaged by it as well. But this is really not very good for the local animals, because the ash is basically shards of volcanic glass. It really is very, very unpleasant and very difficult to breathe, and they're trying to get these animals all rounded up in those circumstances. And then, of course, the ash is just left there, so you have these major issues of trying to clear it. So 1 centimetre thick ash, you may not think that's going to have much of an impact. Again, it's not going to lead to any loss of life in a country like this, but the economic impacts and the broader social impacts can still be quite considerable. And as we zoom out, we just remind ourselves of the fact that that ash cloud travelled much, much further than that. And it was all to do with actually just a particular pattern of the weather systems at the time, which fed the air down here and kept it over here for such a long time. And the really very, very significant economic impacts of that ash cloud, there's plenty of them that you could quote. Things like British airspace closed for 5 days because of the danger presented to aircraft, 95,000 flights that were cancelled, resulting in a loss of $1.7 billion to the aviation industry as a result of that. And so we finish here then with a reminder that although Northern Ireland has a considerable volcanic past, although we're no longer volcanically active, and although we are 1,200 miles away from Eyjafjallajökull, and I suppose if we want to look at some other volcanoes, what about some of the volcanoes in Italy, about 1,900 miles away, kilometers, away from those, we still can be affected by these volcanic ash eruptions that can take place. So there is our world tour. There's us taking a look at these various places. Remember what I said at the start, we need our socioeconomic and environmental impacts, but we need our places so that we can present evidence for whatever opinion you might have, and also so that you can tell those stories. It'll give you your little bit of your depth and detail. So what did we look at? We had our lava flow. What were the two locations for lava flow? In 2018, it's Kilauea, and in 1973, it was Jaime. We had our pyroclastic flows. Okay, Volcan de Fuego is our main example of a pyroclastic flow, although we saw it in Pinatubo as well. Lahar, what was our main example for that? Nevada del Ruiz, and in particular the town of Armero. And again, when we went back to Volcan de Fuego in Guatemala, where we discovered the lahar hazard can hang around for days, weeks, months, and indeed years after the eruption. We saw that in Pinatubo as well. We had a look at ash. Where did we look at for ash? Well, it was 1991 in the Philippines, Mount Pinatubo, when the ash went out much, much further than was expected and caused a lot of the damage there. It also combined with the rainfall to make it heavier to cause building collapse, and it caused the change in the climate for the world for a couple of years. And we've got the poisonous gases that were found in Lake Nyos in Cameroon. So that is our tour. You can use that to help you fill in your poster. Make sure that you know the hazards, the socioeconomic and the environmental impacts, and make sure that you've got plenty of reference to places. And that's what's potentially going to kill you if a volcano erupts.